Bless you. Hi. This is the Chapter 12 practice test we're going to go over. Your test, there are a couple questions on here I will mark off that will not be on the test that we removed from our ISN as well. What do we do for a rectangular prism? Carolyn, bless you. Yes, volume for a rectangular prism, area of the base times the height. Now, when it's a box, does it really matter what part's the base? Not really, okay? So you can really do, on your formula sheet, do you see one that says length times width times height? That's all we need to do. So we just take all those dimensions, 26 times 19 times 8. But a general formula for any prism is area of the base times the height. They didn't draw this one for me, so I didn't really want to think about where the base might be. So just multiply those and tell me what you're getting. I guess I could type it in too. 26 times, was it 19 and 18? Times 18? Oh, 8, not 18. 8. Oopsie, I'll have a big, ginormous number. All right, we got 3,952. And then how do we label it? Just feet? Yes, feet cubed. Or it's really called cubic feet, but I'm not going to mind how you say it. Okay, this is a cylinder, a very flat, short one. We'll need to know its radius, and we'll need to know its height. Well, they told us the 9 inches is the height, but what's the radius? It says the diameter is 30, so the radius is 15. Okay, volume of a cylinder formula. I'm just saying, if you're going to study this test, this is the format with different numbers of the test. You will be successful if you know how to do these. Volume will be pi times the radius squared times the height. That's volume for the cylinder formula that you have on your sheet. You need to be able to plug in the numbers. Pi times 15 squared. I don't have to even put that parenthesis in there. Pi times 15 squared times 9. Make sure you're using the pi key on the calc. All right, so pi times that would come out to 6,361.7 cubic inches. All right. Number 3, a pyramid has a height of 28 centimeters and a base with an area of 20 square centimeters. If you go on your formula sheet and look for volume of a pyramid, it says area of the base times the height divided by 3. You already know the base area, that's 20, so that's your B value. So the volume is going to be 20 times the height is 28 divided by 3. Do you want to draw a picture of it? You don't have to. Okay. I can show you how though. So let's see if we can get that volume first though. 20, because they gave us the area of the base, times 28 divided by 3. Bless you. 186.7. Okay. Cubic centimeters. Or centimeters cubed. If you want to draw a pyramid, you can make a little parallelogram. It's up to you if you even want to do it. I'm going to find kind of where the middle is. Make a little dot. Then I'm going to go straight up from there and make a dot. And then I'm going to connect that point at the top to the corners. My pen is sticking on me here a second. I didn't want to go past there, but the pen was acting weird. So here we go. And then you connect that one to the other ones. And then to draw the height in, you can go straight down from the tippy top. Not that you have to know how to draw one of these, but that's just one way you can get it drawn. Find the volume of the cone. Volume of a cone on your formula sheet is pi r squared times the height. Area of the base, again, is pi r squared because it's a circle. And then you divide by 3. But this one doesn't have the height on it. So we're going to have to figure that out. And then it says that the diameter is 16. So careful. It looks like they're pointing at the radius, doesn't it? So you really want to make sure you read the question, okay? Please make sure you read it. The radius then is not 16. R would be 8 because it says the diameter is 16. All right, now that I know that this is 8, this is 17, that would be the hypotenuse, and I need to find the height, which is a leg of a right triangle. I need to do Pythagorean theorem. So h squared plus 8 squared equals 17 squared. 8 squared is 64, 17 squared is 289. Subtract 64 from both sides, and we'll have h squared equals 225. Take the square root of 225 to solve for h, and that's 15. So now that we know the height's 15, the volume's going to be pi times 8 squared times 15 divided by 3. We found the height was 15 centimeters. Okay, now we go for our calculation. Pi times 8 squared times 15 divided by 3. And even though I'm doing these calculations, I can't stress how important it is for you to be doing them as well. So you remember those keystrokes and how to type it and what it should look like. 1005.3 cubic centimeters. All right, number 5. A right circular cone. A right circular cone. Well, I don't know how a cone could be anything but circular. That's kind of redundant, but it's a cone. And it has a height of 18 inches and a radius that's 10 inches long. Well, the volume of a cone formula is pi r squared times the height divided by 3. So we just got to plug in the h is 18, the radius is 10, find the volume. So we're going to type pi times 10 squared times 18 divided by 3. Now, if you wanted to picture that, you can make an oval, put a dot in the middle, a dot above, and then connect the sides. If you wanted to, you don't have to. This would be a cone with a height of 18, and the radius is 10. That was hard for me to see, but anyway, we plugged it all in. What'd you guys get? Someone? Come on, you're supposed to type it. 1,885 even? Good. Cubic inches. Yes. Yes. Okay, that's good to ask then. So I'm confused as to, let me see what you're referring to. Base area times height divided by 3? You're seeing that? Yeah. The base area, this is the B part right there. Pi r squared. Exactly. So when it says you mean like out in is it in the ISN you're looking or on the formula sheet? Okay. So all the volumes are base area times the height divided by 3 if they're pointy, pyramids or cones. But isn't there a cone one on the picture as well? And it says this, right? Use that. Now, it's still implying that this applies to the situation, but when you're doing a base that's a circle, that's pi r squared. The area of a circle is pi r squared. Does that make it clear? Yeah. So that's why they're showing it. They're showing you that it's still this formula, but they're putting in what the formula is for the base area. Unfortunately, like even if you're doing a regular, say, base, regular pentagon, or this is actually a hexagon, and you had to do this pyramid, oh my goodness, and we're going to come across that today, then you would have to do the area of a regular polygon, which is a apothem times perimeter divided by 2. So that's your big B. And then you'd have to multiply by the height. So they're all the same, except each shape, it depends on what you use in the big B formula, is what shape you have on the bottom. Okay? So that's very important to understand, yeah, why we're using what we're using. Okay, so thanks for asking that you got that clarified. I hope that helped. Okay, a hexagonal prism. Now see, that's what this is. It got a hexagon on the bottom. It's a regular hexagon with sides of 6 centimeters and a path of a 5.2. I can't believe I just actually did that when this is exactly what we're coming across now. So here's what's happening. The bottom of this figure is one of these. It's got an apothem that's 5.2, and it's got sides that are 6. So the formula for the area of this piece, the base, is apothem times perimeter divided by 2. So here we go doing that. What is the perimeter of this six-sided figure? The perimeter would be 6 times 6, which is 36. Are you with me? All right, now I'm only doing the base area right now. Now, I know this is a dumb-looking drawing, but this is basically what this is, okay? And I just made it very ugly, okay? Now, the tallness of it would be coming up from the bottom up to the top, okay? So let's worry about that now. So we're doing the base area is apothem, which they said is 5.2. The perimeter is 36. So we've got to do 5.2 times 36 divided by 2 for my base area. Let's figure that out right now. So 5.2 times 36 divided by 2. I got 93.6 for my base area. And that's in square centimeters. All right, now the next step is for volume to do base area times the height divided by 3. So we just need to take our 93.6. The height of the prism, it says right here, is 15. So we're going to do 93.6 times 15 divided by 3 to get my volume. (93.6 times 15 divided by 3. I could have simplified that, but I chose to just type it all in because that's what most of you do. And I get 468. Is that what you guys got? It was even, 468 cubic centimeters. All right, so it doesn't have multiple choice here. This is just, there might be one on the test that is. A sphere has a radius of 15.6 inches long. Find the volume of the sphere. You look on your formula sheet. Volume for a sphere is 4 pi r cubed, bless you, divided by 3. So we're going to pop in an r of 15.6. You are going to need to know how to type this in. Please practice it, because there's ways you can make mistakes here. So when you do 4 pi times, does everybody know how to put in 15.6 to the third? Anybody forgotten how to put that in? If you didn't practice it in class, you might not remember. You use this arrow up. You put in the 3. Now, what do I have to do now before I hit divided by 3? Yeah, I got to remember to get out of that exponent. I have to scooch over by hitting the right arrow. All right, now I can hit, what was I supposed to be doing? 4 pi r squared divided by 3. Okay, now I got 15,902.4 cubic inches. All right, next. I crossed off that it's not multiple choice. You might have some multiple choice on your test tomorrow, though. 15,902.4. Yeah? Okay, so the next one, volume of a pyramid. These tests are designed so that if you know the basics, you should be able to pass the test. If you know a little more than the basics, you should be in the C mid-range. If you know all of it, you're going to get your A. So, volume of a pyramid again is area of the base times the height divided by 3. The base of this is a square. Okay, that's the B, big B. So you got to do 42 times 42. Now that's your base. Your height's 28. It's all given. So this is a basic question and it tests whether you can follow the formula. Type away and write down your volume. And it'll be in cubic feet. So 42 squared. What was my height? 28? I just did a little shortcut on typing it. Are you guys getting 16? Yep, 46, 16,464. All right, volume of a cone. Here's another basic question. You should know that you have to find the radius if you know the diameter. It would be half of the diameter, so it's 12.5. There's nothing to find. You just need to plug it in. Volume for a cone, pi r squared times the height divided by 3. And again, pi r squared is the base area. So our volume here is going to be pi times 12.5 squared times 30 divided by 3. Okay, please practice. I have forgotten my height now that I'm not looking. 3? 30. I thought it was big. Oh yeah, divided by 3. I was remembering what I was thinking of doing was dividing by 3 first. 4,908.7 cubic centimeters. Okay, so the more work you show tomorrow on your test / quiz, the more I can know what you might have done wrong. I can give some partial credit if somehow you've slipped up on the calculator, okay? Whoops. Oh, this is supposed to be I just made up 20. That's what we used today. I know, I don't know how that got cut off. Somehow the picture slid down and part of the number came off. All right, volume of the cylinder, area of the base times the height. That's all it is. Base area times height. The base is a circle, so that's why it's pi r squared times h. So we do pi times 7.5 squared times 22. You want to know the radius would be half of 15, which is 7.5. Some of you really need a good grade tomorrow on this. Let's go for it. 7.5 squared. My goodness. Once again, I forgot my height. Guess I could look over at the paper. Find one. What was it? 22. Thank you. And it was just a cylinder, 3,887.7. All right. Don't forget your labels. Even if there is no label, you should use a U then if there isn't one, and like U cubed or something. All right, this one, 20 centimeters, I just added on. I know that was chopped off. So you just do 14 times 20 times 16. That's the big box. Please just finish that off. I don't think I need to type that one in. And you put it at cubic centimeters after it. I think most of you are past here anyway, aren't you? Identify the solid. Well, that's a tough one. So somebody made a joke and called it a cylinder in 4th hour. You know what that is. It's a cone. I hope you know. The shape of a horizontal cross-section of this figure. Well, if I went like this and I cut it with a plane, okay, just went, that's what they mean by horizontal cross-section. So I cut through it. What shape would be on the figure? Would it cut out? Well, it would cut out a circle if it's parallel to the base. If it was going vertical, it would cut out a triangle. You think about it. If it went like this through the top and went that way, it would chop out a triangle. Find the height of the figure. Oh, we don't know the height. This pyramid has a height inside there. And then it connects to that right. This is a slant height out here. Now, you only would need the slant height if you're trying to find the surface area. We're not doing surface area. I got to find the height of this thing by Pythagorean theorem again. You see the right triangle? Okay, so what's this length right here that's missing? Yep, it would be 3. It would be half of the side it's parallel to. Okay, and that's 6. Now, if this had been 8 over here, you would have ignored that. You would have done half of the one here because it's going that way. Okay, so we're ready. H squared plus 3 squared equals 9 squared. 3 squared's 9. 9 squared's 81. I subtract 9 from both sides and get 72. Take the square root of 72. And you can tell me that the height's either the square root of 72 or approximately 8.5. Now find the volume of the figure. Area of the base is 6 times 6. Multiply that times the height, 8.5, and divide by 3 because it's pointy. Pyramid. Okay, my pen's stuck there. You want to write down the volume was area of the base times the height divided by 3. The base is the square. Okay. All right, what do we got? 101 point, 102 even? Okay. 102 cubic centimeters. Right, 16. The volume of a cylinder is 62.8 cubic meters and the radius is 2. Find the height. All right, let's write down volume of a cylinder formula. Volume of the cylinder is pi r squared times the height. They have given us V and R. We're going to put in, this is how you decipher, pick apart a word problem. What are you given? What do you know about a formula for volume? And now substitute in for V, 62.8. I got pi in my formula. I got to put in 2 for R. And there's H in my formula. They want us to find the height. All right, now you can evaluate 2 squared. That would be 4. I want to unravel this and get H alone by algebra. What should I do? Caitlin, all right? What would I do? Divide by pi? Okay, let's do it. And I recommend that you do this one thing at a time, else it's very likely to come out wrong. So I'm going to go 62.8 divided by pi. Wait, now did somebody do something else? Don't assume you're wrong if you did something else already. That's 19.99. And then you got 4H left. So how are you going to get rid of the 4? Divide by the 4. All right, then you get on your calculator. I'm just going to divide by 4, the answer I already had on here. And I got 4.99, which is about, rounded to the 10th, would be 5. So the height of the cylinder was 5 meters. Now, you might say, did anybody try dividing by 4 pi? Anybody? Divide by both at the same time? Because that will come out wrong if you type it that way. It will totally, I'll show you. What was it, 62.8? If you go and you divide by everything you don't want, say you hit divided by pi 4, because that's what it was, the order it was in. It's wrong. And the reason is it thinks you said 62.8 divided by pi, and then multiply that answer by 4. That's what it thinks. It's following the order of operations correctly. So the only way that you can do it all at once, I know somebody in here did that, but nobody's telling me. It's if you put parentheses around it. If you're in 4 pi or pi times 4, and then you divided by that whole thing, then you're going to get the right answer. Okay? All right, just wanted to point out that glitch that can happen. Ratio of the side lengths of two cubes is 15 to 13. Find the ratio of the volumes. All right, let's remember. If the sides are in a ratio of A to B, then areas are in a ratio of A squared to B squared. All right, what about volumes then? A cubed to B cubed. I hope that makes sense, that we go from length, area, volume. To the first power, to the second power, to the third power. That's how it works. Okay, ratio of the side lengths is 5 to 13. That would be A to B. So if you want volume, you need to do A cubed to B cubed. So you have to take 5 and cube it, and you got to take 13 and cube it. Okay, those are big. 5 to the third is 125 over, what's 13 to the third? Yep, 2197. Does anybody need me to show them how to cube the 13? Okay. All right, this prism over here is called a triangular prism. It's not sitting on the triangular base, but it's still, its base is a triangle. That's your base. The area of that base would be little b times h, base times height, divided by 2. All right, so you're going to do 12 times 9 divided by 2 to get the base area. That's 54. Okay, now, the base area equals 54. The volume is area of the base times the height. So we're just going to do 54 times how tall is it between the bases on the figure. That's the height right here of the prism. It's the distance between the bases. So that'd be 54 times 8. And our volume for that thing over there, big old chunk of cheese or something, 432 units cubed, or U cubed. Keep a label on everything. Okay, 19. There's an asteroid that will be mined, but they need to know the volume of the thing. Need to know the volume of that asteroid. Asteroids are rather large usually. The diameter of the asteroid is 25 kilometers. Oh my goodness. Based on that diameter, find the volume of the asteroid, assuming that is a sphere. That put one heck of a hole in the Earth. If it's a sphere, because not all asteroids are spherical, 25 kilometers would be its diameter. So what's the radius? Okay, so radius is 12.5. Now, we need to find the sphere formula. So you look at your sphere formula on your paper. It says 4 pi r cubed divided by 3. Pop in the r, and you just use your calculator. All right, it's a little reminder of how to cube something in case you need it. 4 pi times 12.5 to the third. Okay, arrow out of there and divide by 3. All right, our solution should be 8181.2 cubic kilometers. I don't know how you mine that, but it wouldn't be it would not be in a whole piece. You'd have to chop it up. Okay, did somebody still need that? No? All right, 19, and wait a minute. No, we just did 19, right? 20 and 21 are on density, which we crossed out of our ISN. All right, 22. If you did the cross section of a 3D figure, which means cut it with a plane, If it came out that it was a circle, which of these figures could it not be? If you're going to get a circle from a cross section, that thing has to be curved. So it had to be the prism because a cone is curved, a sphere is curved, and a cylinder is curved. Those would all give you circles if you cross section them in a certain way. All right. Okay, pretend you're taking this and you're holding it like it's a stick and you twirl it. What shape will you see as you're spinning it all around? A cone. Okay, good job. Yeah, because it's like going like this and it's going back there. And my pen stopped and I don't know what's going on. Okay, hold it. And then if you thought about it, this is what it would look like. Okay, so it would be a cone. Now, the volume of a cone is pi r squared times the height. We have those values right there on the picture. The r would be the 3, and the height's the 5. So, pi times 3 squared times 5. $141.4 cubic units. Okay. 24. Now, spin the piece of paper, or whatever it is, a rectangle. Spin it around and around and around, and what will you get? A cylinder. That's what, I just sketched it. All right, so you describe it as a cylinder, and it doesn't ask us for the volume, but we could do it. Oh, well, I don't have any numbers, though, so I won't. Are the two figures similar? If so, state the similarity ratio. Last page of our practice test. Okay, you take and compare 32 to 80. Grab your calculator and reduce that fraction. Remember, you just hit 32 divided by 80. You go to math, enter. Gives you 2/5. All right, now compare another pair of sides. 12 to 33. You can divide those by 3. 12 divided by 3 is 4. 33 divided by 3 is 11. Are these equal? The comparison of the sides is not congruent, so they are not similar. Okay, 26, you do 42 is to 21. You reduce that to 2 to 1. Then you check the other side, 30 to 15. And that reduces to 2 to 1. So yes, they are similar. And the similarity ratio or scale factor is 2 to 1. You can write it with a colon or as a fraction. Anybody still need this? Given the volume of the similar figures, state the ratio of similarity. Well, wait a minute, guys. Look, A to B, that's the sides. A squared to B squared, that's the areas. A cubed to B cubed, that's the volumes. What do you got? You got the cubes. You see the m cubed? All right, so I know I'm dealing with this right here. I want to go back to there. How do you uncube? Well, let me ask you this. How do you unsquare? You take the square root. Okay? And notice, guess what? If you want to uncube, you have to do the cube root. Okay, so the cube root of a cubed to b cubed will give you a to b. All right, and that's what we want. So we need to do the cube root, index of 3. By the way, on a square root, the index is 2. They just don't write it there. It's unsquaring. All right, so we're going to do 6517 divided by 19,000. And I'm going to type just like that on my calc. I'm going to go to Math, Choice 4. That's cube root. Now you see the little 3 there? Now I'm going to put in those numbers. And now I just got to remind myself what they happen to have been. 6517 divided by 19,000. Let the calculator do the work here. Now get out from under there. Get out of the radical. Crazy people in there. Okay, then hit Math. Enter, enter to get a fraction back. 7 out of 10. That's your similarity ratio. Okay, so the similarity ratio is 7 to 10. Or 7 over 10. I don't usually write my fractions slanted like that, but that was really big numbers. All right, 29, given the volume, we just did the problem. All right, now, given the similarity ratio of 1 to 5, this is on your final exam right here. Find the volume of the larger figure if the small, oh wait, I just know that you have to know how to get the volume ratio. Find the volume of the larger figure if the smaller has a volume of 240 cubic inches. All right, this is the similarity ratio. That's A to B. We need to do volume, so we need A cubed to B cubed. Okay, so first step. Take 1 and cube it, take 5 and cube it. And write a proportion. It says, find the volume of the larger figure. So that's going to be on the bottom. Oops, I'm going to use a V, not a A. And then up here would be the 240. And you can just cross multiply and divide now. Or you could evaluate these if you want. And then do the proportion. But 1V is going to be 125 times 240 or 5 cubed times 240. I do not know what that is off the top of my head. 30,000 even? Like that? That's the number you guys got? All right, and that'll be in cubic inches. Okay, almost to the end here, close. A hot water heater is shaped of a cylinder. Find the amount of water it will hold. Okay, this would have a radius of 8 because the diameter is 16. Volume of a cylinder is pi r squared times the height. So we're just going to pop in some numbers. Pi times 8 squared times 48. Okay, so I've got 9,650. Oh, that would be 51. 9,651 cubic inches in that tank. Doesn't sound like a very big tank, actually. Maybe 4 feet tall. The scale of 2 similar swimming pools is 4 to 11. The amount of chlorine mixture is to be added is proportional to the volume of water in the pool. All right, so if this is the scale factor, we need to do volume. We need to do 4 cubed to 11 cubed. That's your volume ratio. All right, now, if 3 cups of water go in the little pool, how much chlorine mixture is needed for your big pool, the larger one? So where should I put 3 cups? Top. And we'll need how many cups, whatever, C on the bottom. Now, guys, you can just type 11 cubed times 3 divided by 4 cubed. Do you understand that? I mean, if you did cross products, it'd be 4 cubed times C equals 11 cubed times 3. And you would divide then by 4 cubed. So I just didn't want to evaluate those numbers because they're kind of big. So I'm just going to type it like that. 11 cubed. Oh no, I did 33. That would be ginormous. Okay, get out of there. What was I multiplying? I can't remember now. Times, I gotta pay attention here. 3 divided by 4 cubed, right? There we go. Where's my arrow? 62.4 cups. A lot of chlorine. Find the volume of each figure. This has a base that is a regular polygon. The base area would be apothem times perimeter divided by 2. Okay, I'm just going to tell you, you need to find the perimeter. That would be 30. And then you're going to put it in here. The volume is going to be base area times the height, which will be 11, divided by 3. So you got to find this and pop it in there. This one, don't divide by 3. Okay, base area. I think I'm going to finish this off after you guys are gone, and I'm going to post it to Classroom. Okay, so to finish this one, the area of this base, again, is apothem times perimeter divided by 2. It's got 5 sides, so I did 5 times 6, the length of one of those sides, to get 30. Now that's the perimeter of the base. The apothem is 4.1, so I'm going to pop in 4.1 times 30 divided by 2 to get my base area. 4.1 times 30 divided by 2, following the regular polygon formula, is 61.5. So I'm putting in 61.5 now. And I will multiply that by 11 and divide by 3. So 61.5 times 11, I can just type that now that I have it on my calculator, divided by 3. And that's because it's a pyramid that we're dividing by 3. 225.5 cubic kilometers. Okay, and the last question is a prism, and it's a hexagonal prism. Its base is a hexagon. Again, area of the base would be apothem times perimeter divided by 2. The apothem, A, is 7.8. The perimeter of the hexagon would be 9 is the length of each side. So there's 6 of them. So perimeter is 6 times 9, which is 54. So I've got to do 6.8 times 54 divided by 2 to get the base area. 7.8 times 54 divided by 2. So my base area is 210.6. All right. Now, volume. Area of the base, 210.6 times the height, and the height is 4. And that would be your volume. So all I have to do is go back to my calculator, multiply that value by the height, 4, and I will be done. No dividing by 3, this is a prism, 842.4 cubic miles. Okay, study and be ready for that test tomorrow.